find the solution of this differential equation. Now we've got to check whether this equation is the exact equation or not. Okay, m is the x plus 3 times x to the power 3 times sine y. N is equal to x to the power 4 times cos y. Derivative of m by y equal to what? The first term, we look at x as a constant. What we get for the first term? 0, right? Because you do derivative by y. You look at x as a constant, so you would get 0. And the second one, 3x to the power 3, you look at it as a constant, so you would get plus d sine y by dy. Derivative of sine y by y equal to cos y. So you would get 3x to the power 3 cos y. Now, derivative of n by x. You look at cos y as a constant. So you would get cos y dx to the power 4 by dx. What you get? 4 x to the power 3 cos y. Equal or not equal? Not equal, so it is a not exact equation. But if you look at the function itself, it's so hard to find other way to get the final solution. So the best way is finding an integrating factor. Okay, what is the case 1? Case 1 said that if you have m dx plus m dy equal to 0 and that equation is not exact equation, then you can, if you have this term 1 over n, find the difference of m by y minus 2n by x. If this term is a function of x only, then we can find the integrating factor by using the formula that is given to us, right? Now we got to find whether this one is a x only, is a function of x only. Okay, so you already, the thing is that if you did this term, these two terms wrong, you wouldn't be able to get this one right. Okay, so go practice derivative things. Okay, what you get from that? Can these two terms subtract to each other? Yes, it is, right? Because you have x to the power 3 cos y for both terms. So 3 minus 4 is equal to minus 1. So you get what? Minus 1 over x, which is a function of x, right? So in this case, you can find integrating factor as an exponential of integral fx dx, which is equal to exponential of integral minus 1 over x dx, which is equal to negative what? Ln x, right? So the integrating factor is 1 over x. Now I said multiply differential equation, differential equation by 1 over x. So I would get 1 over x times x plus 3x to the power 3 sine y dx plus x to the power 4 divided by x cos y dy equal to 0. Right? Because I just multiply by 1 over x, I would get this. Okay, just make it nice. 1 plus 3x to the power 2 sine x, sine y dx plus x to the power 3 cos y dy equal to 0. Now we check whether it is an exact equation again. Our m now equal to 1 plus 3x squared sine y, and n is equal to x to the power 3 cos y. Derivative of m by y and derivative of n by x now is equal to what? The first term equal to 0 again. The second term, derivative of sine y is equal to cos y, right? So you would get 3x squared cos y. Now, derivative of n by x, you look at cos y as a constant. So you would get what? 3x squared cos y. Now, they all are equal, become exact equation. Now, the way to find the answer for this equation, you can find by exact equation method by using the equation after you multiply by integrating factor. Okay, df by dx equal to n. So f equal to m dx integral, which is equal to integral 1 plus 3x squared sine y. Okay, so you've got integral dx plus sine y integral 3x squared dx plus dy again. Integral dx equal to x, right? Integral 3x squared dx equal to x to the power 3 and then times sine x. Sine y. Okay, again, because we don't know what's dy and we need to find dy. Dy we find from n. Now, because we know that our f is equal to x plus x to the power 3 sine y plus dy. So we dip f to y. If we dip this f to y, the first term equal to 0, the second term equal to what? right? And then we plug this one back in there. We got right, and then we got dy equal to 0. If we integral this one, we would get the constant, right? So we don't really have function of y. So the answer is that our fxy is equal to x plus x to the power 3 sine y equal to c. If we do the other way, by integral both fx to find fx and fy, and then we do union thing. Okay. We would get x plus x to the power 3 sine y, and then we do derivative of n to y to get fy, integral cos y dy equal to sine y. So you do union, but you get x plus x to the power 3 sine y equal to c. That is the final